Ethical Conduct Notice. This tutorial is intended solely for educational purposes and authorized penetration testing. Engaging in any form of unauthorized access or exploitation is illegal, unethical, and strictly prohibited. Always ensure you have explicit written consent before conducting any security assessments. Use your knowledge to strengthen cybersecurity and always uphold the highest standards of professional integrity. Welcome to the Web Security Bootcamp channel. Ever wondered how hackers actually break into websites using SQL injection? This beginner-friendly video will introduce you to relational databases, the foundation you need before diving into SQL injection. Even if you're brand new to databases, don't worry. By the end of this short video, you'll have a clear understanding of how databases work and how different tables relate to each other. So, why is it important to learn about relational databases before diving into SQL injection? Whether you're a security researcher, ethical hacker, or penetration tester, it's essential to understand how databases work, their structure, how they're queried, and where vulnerabilities can arise. This foundation helps you spot common issues like SQL injection and privilege escalation, simulate real-world attacks safely in ethical lab environments, and strengthen systems by identifying weaknesses before attackers do. In this video, we'll focus only on relational databases because they're the most commonly affected by SQL injection. Let's get started. In this video, you'll learn the basics: what a database is, where it lives, and how relational databases actually work. To make it easier to follow, we'll walk through a simple example, an online bookstore, to show how data is stored, connected, and retrieved. Let's start by answering the most basic question. What is a database? So, what is a database? It's a digital collection of organized information managed by special software called a database management system, or DBMS. The DBMS helps apps store, retrieve, and update data efficiently, keeping everything structured, searchable, and secure. What kind of data do databases store? First, they store user data like usernames, hashed passwords, emails, and session tokens. This is the information users provide when signing up or logging in. Then we have application content, posts, messages, comments, products, reviews, and metadata about uploaded media. Next is business logic data, which supports the app's core functions. This includes transactions, subscriptions, invoices, task statuses, and inventory. And finally, there are system and audit logs. These track errors, inputs, and user actions. Logs are crucial for debugging and spotting suspicious activity. When you visit a website, whether you're logging in, submitting a form, or just viewing content, that site needs to talk to a database. But where is that database actually stored? Databases are stored in various locations depending on the system used. They can reside on physical servers in dedicated data centers, using local hard drives or solid-state drives. Virtual servers hosted by platforms like Amazon Web Services or Azure store databases in virtual storage systems. For smaller applications, databases such as SQL can exist directly on your local device. Finally, cloud-managed services securely handle storage in specialized cloud environments. Now, take a moment to reflect. Question 1. What kind of information does a database usually store? Question 2. Where is a database stored in a typical web application? Drop your answers in the comments. I'd love to hear your thoughts. There are many types of databases, but they can generally be divided into two main categories. First, we have relational databases like MySQL, PostgreSQL, and SQLite. They store data in tables, and we interact with them using SQL or structured query language. Then there are NoSQL databases like MongoDB, Firebase, and Redis. They use more flexible data formats like documents or key-value pairs and don't use SQL to manage the data. In this video, we'll focus only on relational databases, as they're the ones most often vulnerable to SQL injection attacks. Since relational databases are built around structured tables, let's break them down by starting with how those tables are created and related. So, what exactly is a relational database? A relational database organizes information into tables of related data, which are connected to each other through relationships. Each table is made up of rows and columns. Rows store actual records like a user, an order, or a product. Columns define the type of data, such as a name, email, or price. Two key concepts help link tables together. A primary key is a unique identifier for each record in a table. A foreign key is a value in one table that links to a primary key in another, allowing tables to be connected. This structure helps keep data organized, consistent, and easy to work with. Don't worry, we'll look at a real example in just a moment. Let's take a look at how relational databases store and link data using tables. Here we have two tables from an online bookstore, customers and orders. The customers table stores user information like name and email and assigns each person a unique ID called customer ID. The orders table records each purchase. It includes the order ID, the order date, the total amount, and the customer ID of the person who placed the order. The key detail is that customer ID in the orders table is a foreign key. It links each order back to a specific customer in the customers table. This relationship helps the database understand which orders belong to which customer, a core idea in how relational databases work. Now let's look at two more tables, books and order items. The books table stores details about each book, including its unique book ID, title, author, and price. The order items table connects specific books to specific orders. It's what we call a junction table. This table contains two foreign keys: order ID, which links to the order, and book ID, which links to the book being purchased. It also includes a quantity column, which tells us how many copies of each book were ordered. Thanks to this structure, we can answer questions like, what books were included in order 1001? How many copies of Clean Code have been sold? These relationships built using foreign keys are what make relational databases so powerful. And they're exactly what SQL is designed to work with. In relational databases, keys are special columns that help define relationships between tables. A primary key is a column that uniquely identifies each row in a table. For example, in the customers table, the column customer ID is the primary key. Every customer has a unique ID, no two customers share the same one. This makes it easy to find and reference specific records. A foreign key, sometimes called an external key, is a column in one table that refers to the primary key in another table. In our orders table, customer ID is a foreign key. It links each order to a customer in the customers table. This is what creates the relationship between tables and allows us to connect data across them, like seeing which customer placed which order. In a relational database, tables are connected to each other using keys. When designing a database, developers define how tables relate by assigning specific columns as primary and foreign keys. The entire layout of these relationships is called a schema. Let's look at our online bookstore example. In the customers table, customer ID is the primary key. This same column appears in the orders table as a foreign key, linking each order to the customer who placed it. In the order items table, there are two foreign keys: order ID, which connects each item to the orders table, and book ID, which links each item to the books table. These connections let us ask powerful questions like, which books did Sophie Tracy, customer ID 1, order? This is what makes the database relational. Tables are linked together by key fields to create a structured, searchable system. Now pause the video and try this challenge. Can you figure out what Oliver Jake and Jack Connor ordered? Write your answers in the comments. I'd love to see what you come up with. Great job making it this far. Let's quickly review what you've learned in this video. You now know what a database is, what kind of information it stores, and where it can be located, whether on a server in the cloud or embedded in an app. You learned the difference between relational and NoSQL databases and saw why we're focusing on relational databases first, since they are most commonly targeted by SQL injection attacks. You understand how relational databases use tables, rows, and columns to structure data, and how primary keys and foreign keys connect everything together. And you explored how an online bookstore could structure its data across multiple tables. This foundation is essential, especially if you're preparing to learn about SQL injection and other web security issues. In the next video, we'll take the next step. You'll learn what SQL is, how it's used to query data, and how attackers can exploit poorly written SQL statements. So be sure to subscribe or follow the playlist if you're ready to level up your security skills. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. If you have any questions or suggestions, please write them in the comments. See you in the next video.